Hello everyone, my name is Daniel Mashlov and I'm honored to be here at BazelCon. Today I'm going to tell you about how we're using Bazel at VMware to create a more efficient developer workflow for our OSS compliance process. I've worked on this project closely with Rihanna Tabasum, Haipeng Wu, Mark Zarin, Andrew Pasaltis, and several others at VMware. We hope that this presentation and our work will contribute to the design of general purpose licensing infrastructure for the Bazel community. With hundreds of thousands of open source projects for a developer to choose from, open source software is a vital component for almost any code base, sometimes making up over half of a code base. And with the plethora of open source licenses available, each requiring unique care, complexity of managing open source software cannot be overlooked. At VMware, like many other organizations, product releases must comply with legal and license requirements of open source software. However, the complexity to meet these requirements often adds friction to the development cycle. To solve these problems, we came up with a new open source license compliance developer workflow using Bazel. In this presentation, I'll give you a little bit of background about open source license compliance. Then I'll expand on our current workflow. And finally, I'll tell you about our new approach. In order to comply with the licenses for the open source software that VMware uses in its codebase, we must first identify all the open source packages that we're using. This is like having a haystack full of needles and needing to find each one of them or face legal and security risks. Second, all of the open source must be tracked, so legal and security teams can approve or deny the packages. If a package is determined not to be fit for use at VMware, it must be removed and the code must be refactored. Third, we must be compliant with the licenses of the software that we use in our products by producing proper documentation upon product release, where documentation requirements vary by license and package. The ideal scenario is to have an efficient process for identification and tracking of open source in order to reach license compliance with the least amount of toil. The way in which open source compliance is accomplished varies by company. Let's take a look at the current workflow being used at VMware. In the current workflow, there are two strategies for a developer to gain approval for open source package usage. The first option is to run a local build, then use a CLI tool to scan for open source, and another CLI tool to upload tickets to our internal OSS review tool. The second option is for a team to set up a continuous integration pipeline where, after developers check in code, new builds are triggered, the latest build artifacts are scanned for open source, and tickets are created for any newly added open source packages. After tickets are filed to the OSS review tool, people from the legal and security teams review the packages asynchronously. If any packages are denied for use, developers are notified and the package must be removed. To improve the efficiency of our process, we set out to design a new developer workflow using Bazel. In our new approach, we aim to improve the developer workflow for identifying and tracking OSS components for the product builds using Bazel. Our primary focus is set on removing toil from the developer workflow for meeting OSS compliance while maintaining a high degree of accuracy and due diligence. By creating and applying a new Bazel rule during the build process, which we call OSS audit, we can precisely identify direct and transitive OSS dependencies. We combine the OSS dependency insights from Bazel with licensing and usage information from VMware's internal OSS review and compliance tool. This benefits our developer workflow for meeting OSS compliance in several ways and has been adopted by a growing number of VMware's product builds. First, developers get a deterministic bill of materials with every build. The BOM contains all the direct and transitive dependencies of a product paired with licensing information and approval status from our OSS tool. Open source scanners from VMware's current compliance process cross-check the correctness and completeness of the Bazel-generated BOM. In the case where the BOM is incomplete, it can be supplemented with build steps that scan individual inputs. Second, developers are notified at build time if the product contains OSS dependencies that have been denied for use by legal or security teams. This is a process that could previously take days. This is done by cross-checking each OSS dependency against its approval status in the OSS tool. The third benefit is that Bazel's multi-language support allows us to have one tool that works cross-platform. OSS Audit supports OSS identification in Java projects built by Bazel, but we're currently adding support for C++ builds and will support other languages soon. Because we create a BOM and validate approval status of OSS with each build, open source decisions are made earlier in the development and review process, making them less costly and less likely to impose release delays due to required remediation. Let's take a look at an example of how this new developer workflow using the OSS audit rule. We start with the Bazel build that just produces an RPM package with the project source files using package RPM as seen here. The OSS audit rule consumes a Bazel aspect that analyzes the dependency graph of a build and collects information about each package. Additionally, it consumes a list of previously approved and denied OSS packages, usually determined by a legal or security team, to validate the build dependencies are approved for use. After the aspect traverses all the dependencies, OSS audit outputs two files. First, it creates a BOM YAML file, which includes all information on each OSS package. Second, it creates a BOM issues file containing a subset of OSS packages that have been denied for use by the legal or security teams, or that are still waiting for approval. Release managers and developers can use the BOM issues file to identify problems that may block or delay a product release. This is the workflow for using OSS audit. Now let's look at how this happens in action. This is how the OSS audit rule can be added to a build file to audit an RPM. In this example code, you can see that package RPM rule below, creating the RPM, and the OSS audit rule above, auditing the RPM. This solution can audit RPMs, TARs, and other build targets, such as Java binaries. The approved and denied lists inform OSS audit about which packages are approved and denied. These lists are used to provide extra data to be included in the bill of materials, such as copyright notices and information about how the package is used. Let me show you a demo where I'll apply OSS audit to a simple example project. The project that we will be auditing is an example project from the Bazel build repository on GitHub. It is a Java application that compares two numbers using the in-stock compare method from Guava, seen here. Guava is an open source project, and looking at the workspace file, you can see that we import it using the Maven install from rules JVM external. Checking out the build file for this project, you can see that there's a Java binary that, when built, produces a jar. And we could go ahead and audit this Java binary directly. But to make things more fun, let's package this jar inside of an RPM package. So using rules package, I'm going to add in some code to do that. Here's the code we need for that. And now we can go ahead and audit this RPM. And here's the code we need for that. OSS audit has a source of the target it's going to audit. So in this case, it would be the RPM. Additionally, it has the approved and denied lists. Our approved list has one entry. This file is structured where the key is the package identifier and the values are information from the OSS review tool. At the moment, our denied list is empty. Okay, once we're ready, we can go ahead and audit this RPM. The output is a BOM and BOM issues file. I'll open up the BOM first. So looking at this BOM file, you can see that there's several entries. The format of this file is the key and value pair like before, where the key is the package identifier and the value is various pieces of information about the package. Now, if you remember, we were only depending directly on Guava, which you can see here. And so the rest of these packages are the transitive dependencies of Guava. Our copyright notices that we added into the approved list are now showing up in the BOM. And the rest of this BOM.yaml file are more transitive dependencies. Okay, so now let's check out the BOM issues file.
The BOM issues file has all of the transitive dependencies that we saw in the BOM that are not added to the approved list. So once these files get added to the approved list, they will be out of this BOM issues file. Cool. So what happens when we add a package to the denied list? Let's check it out. So we can uncomment this package, find bugs JSR 305, and let's go ahead and save the file, then run the audit again. So this time we get a failed build, and we have an alert message letting us know that we're not allowed to use this package, find bugs JSR 305. And that's great, but sometimes it's not the most convenient time to remove a package from the code base. So what a developer can do is head over to the build file, and they can add a suppressed list to the OSS audit, which tells OSS audit not to fail the build because of these packages that are denied. So we've added find bugs JSR 305, and we've tagged it with the build number so we know to come back and remove this from the code. I'm going to save this file and then run the audit once more. This time, the audit succeeds, but we're still left with the alert, letting us know that we should eventually remove find bugs JSR 305.
And that's an example of how to apply OSS audit to an example project. Let me show you a few examples of how we use OSS audit at VMware. The OSS audit outputs can be inputs to other processes for legal and security approval. At VMware, automation uses the BOM to file OSS review tickets for newly added packages, so people in the legal and security teams can review the packages asynchronously. This automation also queries the OSS review tool for the most up-to-date list of approved and denied packages, and submits them back into source control for use by the next build. Now, if any packages are denied for use, developers are notified the next time the build runs. This is how we've integrated OSS audit with our existing OSS review tool. To wrap up, let's check out one more application of OSS audit for use in bigger projects. At VMware, we have some larger products that are constructed of many services. In this case, OSS audit is used to generate a BOM for each service. These service BOMs are then merged together to create one top-level BOM and BOM issues file for the entire product. This gives product and service teams insight into what they're shipping at varying degrees of granularity. So far, I've shown you our current workflow, our solution, and a couple ways our solution can be extended. In summary, OSS is a critical piece to almost any code base, but the complexities of identifying and tracking it slow down the development process. Using Bazel as our foundation, we're able to validate OSS usage at build time and produce a BOM containing all open source used in a code base. This gives developers immediate feedback, removes tedious extra steps, and provides a single cross-platform product-agnostic tool. We're interested in engaging the Bazel community to see what kind of OSS compliance solution would work for the ecosystem. And we're looking for feedback on this solution to help it evolve. Our call to action is to visit our GitHub, check out the code, and even open an issue to continue the discussion. Thank you very much for tuning in.